Although I learned OOP practices in my university programming courses, I recently came across Bob Martin's solid principles, and after studying up on them, I decided to make a program for each principle to not only demonstrate my understanding of the principles, but also because one of the best ways to learn something well is to teach it. Keep in mind, I've tried to make each program as simple as possible, so we're only going to deal with one principle at a time, and for simplicity's sake, I might leave out some important code here and there, like memory deallocation or deconstructors and header files. That being said, let's get to the content. Alright, dependency inversion principle. This one's kind of hard to grasp, so I went ahead and made two different examples. I'll do one example verbally, and then I'll code one example. Sometimes you need to make an object that's made out of other objects. For example, if I were to make an object called house, it would have to be made up of other different objects like bedroom, oven, and fireplace. One way to go about this is to instantiate these objects inside of the house class. So whenever we make a house class and the house constructor is called, it will also create a new bedroom, oven, and fireplace. But why is this bad practice? That's because we have to make a new house class whenever an object in our house changes. For example, let's say I make a house called McMansion 1, and then I want to make a house called McMansion 2. Let's say these house objects are exactly the same, except they have different ovens. Since the house class already has a certain type of oven that it has to make whenever it gets created, I'll have to make a whole new house class for McMansion 2, just so I can put a new oven in there. Now you can imagine, if I had 4 different types of McMansions, and 4 implementations of each of those, but each implementation was slightly different, that would be 16 classes. Now to solve this problem, we'll do 2 things. First, instead of creating the oven inside the house class, let's create the oven outside of the house class, and we'll just pass it in through the constructor of the house class. Now I know what you're thinking, our constructor will still need a type. This is where step 2 comes in. Step 2 is that we want to make any class, such as a house, which depends on other classes like oven, depend on an interface instead. This way, when we create a McMansion object from the house class, it can take any type of oven. Now, we can create 2 McMansions using the same house class, even if their ovens are different. This is because when we create, each time we create it, we pass a different oven into the McMansion constructor. The first McMansion will take a gray oven in its constructor. The second McMansion will take a black oven in its constructor. Now that explanation was a bit abstract, so here's a simple yet concrete example that uses car and engine objects. So you can't have a car without an engine. So our car class, or car object, relies on our engine class, or engine object. The car class creates an engine for itself whenever we call the car class constructor. And our engine has some specific data it wants to keep track of. Now moving on to our main function, we create a Honda Accord from the car class, and when we create the Honda Accord, it creates its own engine. This is great, because Honda Accords use inline 4-cylinder engines, and that's exactly what we're implementing here. However, what if I wanted to make a Honda Civic? Well, sure, I could just create a Honda Civic class, which creates an engine for itself whenever we create a Honda Civic. But what if we need to make 3 different types of Honda Civics? Say a standard Civic, a Civic Si, and a Civic Type R. They're all the same except for the engine. They have the same number of seats and the same parts. They don't in reality, but we're just pretending they do. So should we really have to create a new car class every time the engine changes? No, we shouldn't. So here's what we did instead. We created an interface for all our engines, which makes creating new engines a lot faster. And we have 2 different types of engines, which both share the parent class of the iEngine interface. We created an interface for our car classes as well, which of course creates engines. But notice when we create a car object, such as Honda, it takes an engine interface as a parameter. Because of this, we can pass any engine into a Honda instance. More specifically, since we have an interface, iCar, that can be given any object of another interface, iEngine, we can interchange the cars and engines however we want. Here's a concrete example. We have a Honda V8 engine, and we can give that engine to our Honda Accord. We also have a Honda V6 engine. We can also give that to a Honda Accord. Same Honda class, but we gave it a different engine. So to summarize, dependency inversion keeps your objects from relying on concrete implementations of other objects, and instead makes them rely on an interface. And if the object that you pass them is created from that interface, then it's fair game. This makes changing your code and reusing old code much easier. Say whenever a new Honda Civic model rolls out, or we already have a certain type of engine and we want to pass that engine to a certain type of car that we already have, instead of making a whole new class that links those two together, we can just use our existing classes